Yet she claims she had to go out of town suddenly. She's avoiding me. She doesn't want to tell me where my father is.
All right. In today's lesson, we're going to learn about the angles that we learned about yesterday and what's true about them when the lines cut by the transversal are parallel. So to begin today's lesson, let's review the angles that we learned yesterday. Remember, corresponding angles, two angles that occupy the corresponding positions, such as 2 and 6, both above the lines to the right of the transversal, 1 and 5, above and to the left of the transversal, 3 and 7, below and to the left, and 4 and 8. Notice that they're occupying the same position. To help you think about the corresponding angles, you can always think about using an F shape. If I trace an F, you can see that 4 and 8 are the ones that are in the same spot. The other angles we learned about yesterday, the alternate interior angles, the alternate sides of the transversal, and they're interior of the parallels, but they can't be adjacent. Same side interiors are on the same side of the transversal and interior of the parallels. Alternate exteriors, again, alternate sides of the transversal and outside of the lines. And the same side exteriors, which is new, which we didn't learn about yesterday, same side of the transversal, outside of the parallels. So let's talk about our first one, the corresponding angles postulate. If a transversal intersects two parallel lines, then corresponding angles are congruent. So in our diagram, 1 would be congruent to 5, 2 would be congruent to 6, 3 to 7, and 4 to 8. The lines in the diagram to the left are parallel, then all these angles are congruent, as I just mentioned. 1's congruent to 5, 2's congruent to 6, 3, actually I should say 7, 3's congruent to 7, and 4 would be congruent to 8. Let's learn about another pair. Let's talk alternate interior angles. Here's our diagram. So we're going to show something about 3 and 6, and 4 and 5. Given that L is parallel to M, the two lines are parallel, T is the transversal, prove that 3 is congruent to 6. Our proof would look like this. We're given that L is parallel to M. 2 would be congruent to 3 because they're vertical angles and the vertical angle theorem would apply. 2 is congruent to 6 because the lines are parallel and the corresponding angles postulate. And by the transitive property, since 2 is congruent to 3 and 2 is congruent to 6, thus 3 would be congruent to 6, and thus alternate interior angles theorem. Here is the official theorem. If parallel lines are cut by a transversal, then the alternate interior angles are congruent. According to the alternate interior angles theorem, which these angles are congruent, 3 would be congruent to 5, 4 would be congruent to 6. Remember, alternate interior angles, you're looking at a Z shape. Example 1. Find the value of x if A is parallel to B. Well, notice that these two angles are alternate interior angles, and by the alternate interior angles theorem, they must be congruent. So we could say that 5x minus 54 would equal 3x plus 16, and then we'll solve it. So we'll use the subtraction property of equality and subtract 3x on both sides, resulting in 2x minus 54 equals 16. Then we can use the addition property of equality, add 54 to both sides, 2x equals 70. Finally, by the division property of equality, we'll divide both sides by 2, and we discover that x equals 35. Next. Pretty much the proofs would look about the same. We'd use the corresponding angles postulate to start with, and then use vertical angle theorem, and etc. So I'm not going to present the proofs. But the alternate exterior angles theorem. If two lines cut by a transversal are parallel, then the alternate exterior angles would also be congruent. Again, 5 would be congruent to 1 because they're corresponding. 1 and 2 are congruent because they're vertical, So by transitive, 2 would be congruent to 5. So the theorem is simply this. When two lines are cut by the transversal, the alternate exterior angles are congruent. Same side interior angles. These are the only ones that are different. They're not congruent. Correspondings are congruent. Alternate interiors are congruent. Alternate exteriors are congruent. The same side interior angle theorems are these. They are supplementary. Again, 5 and 4 form a linear pair, which would make them supplementary and add up to 180. But 5 is congruent to 1 because they're corresponding. Therefore, replacing 5 with 1, 1 plus 4 equals 180. The only one that's different. And again, to think about your same side interiors, look for a C shape. Follow my pointer, you can see the C. Example 2. What are the measures of 8 and 4? Explain. Well, since A is parallel to B, noted by the two arrows in the middle of the lines, angle 8 and angle 115 are supplementary because they're same side interior. Therefore, 8 would be 180 minus 115, or 65, by the same side interior angles theorem. For 4, we'd use M and N, and since M is parallel to N, angle 4 equals 115 by the corresponding angles postulate. And that ends today's lesson.
I took this picture from your fridge, okay? Because I know that this is my father. Yeah, this is Frank Buffet, and you were standing right there next to him. Now, look, I deserve to know where I came from.